Hey everyone. So let us talk about this lead code problem, valid perfect square. So you are given a positive integer num, return true if num is a perfect square or false otherwise. So what is a perfect square? A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. And we are not supposed to use any built-in library function such as square root or something. Okay. So for example over here, if you're given num as 16, we return true. Why? Because 4 square is 16. Okay. So for this problem, we'll be using binary search. And let me explain over here. So let's say, okay, uh, 1 minute. All right. So let's say you are given num as 16. Okay. So how we'll be using binary search? So the question is that we need to find the square root of this 16 and whether it is a proper integer, then we return true. Okay, so for of square root, for example, of 15 would not be a proper integer. It would be something like 3.9 or something like that. Not sure, but it would be some decimal number. So we return false in this situation. Okay, so our approach would be to go and look for a number and then find whether it is equal to 16 when you square it. Okay, so let's say if you start from 0 to 16, okay, in between till 16. So you take this number, square it, whether you get 16? No. If you take this number 1, so 1 into 1 is equal to 16? No. Then you go to the next number and so on and so forth. And when you reach 4 over here, and if you find 4 into 4 is equal to 16, that means you return true. Okay. So in this situation, we know that we can take the lower number as 0 or 1, any of it, and the upper number as this number 16. Okay, and then what we'll do is we'll do a binary search. We'll find the middle number, let's say somewhere around here, which is 8, and then we say whether 8 into 8 is equal to 16. No, it is not equal to 16. Whether 8 into 8 is greater than 16. Yes, it is greater than 16. Why? Because we get 8 into 8 is 64. So then we traverse towards the left, and then do some we do a binary search again. We get to a middle point 4, and then we say whether 4 into 4 is equal to 16. If it is equal to 16, then we return true. So basically, we'll be doing a binary search on this number system. We'll get to each number and find whether if you multiply that number by itself, whether you get this num. And so we'll be able to find out whether it is a perfect square or not. Okay, so let's just look at the code. Okay, so let me initialize the lower value as 0, high value as num. So while we run a while loop from low to high, okay, and we'll get the middle point. So we do math.floor. We say low plus high minus low and divided by 2. Okay, now we calculate the square. So let square equal to mid into mid. Now if we check, if square is equal to num, if it is equal to num, then directly return true. We have found our a number and we know that it's whatever we are trying to find, this num is a perfect square. Now, if square is greater than number, that means we have to move towards the left. Over here, in case of 64, 8 into 8. Okay. Uh, it's not equal to 16, it's equal to 64. So 8 into 8 is 64, which is greater than num. So we have to move towards the left over here. So we'll have to update the high pointer. So our high will become mid minus 1. Else, we have to move towards the right. Why? Because whatever square that we have found is lesser than the number that we are looking for. So we'll have to say low is equal to mid plus 1. Okay. Now if the entire loop is complete, that means we were not able to find this, and that is why we have to return false over here. Okay. So this is how you use binary search in this problem. Let's just run this and see if the code works. Okay, so we got an acceptance on the test cases. We'll submit it. Okay, so this answer is accepted.